Okay, this is a video specific for this clip. So there's a lot of things you could do within Fusion, of course. You can, sketch up your own drawings and, make your own tweaks and whatnot. But since we have a model to start with, I like to, kind of work smarter, not harder, if you will. You have an STL, and so in Fusion, that's always going to be best suited if you do this insert mesh. I find that if you go through this option and you try to upload and open it that way, usually the dimensions are all over the place, right? They're never what they're supposed to be in my experience. So what I do is I go to insert mesh. I find wherever that file was located here. I just put it on my downloads folder, and it's going to bring it in to uh, the workspace here. Now, advanced tip, we're gonna CNC this, so I'm just gonna lay this flat real quick. Other than that, we don't really need to worry about its orientation. Now from here, obviously you got a bunch of faces, but what I found is that if you go into the mesh tab and you generate face groups, select your model and hit OK, it's going to kind of blink for a moment there, and it's going to do its thing. Now we're going to go in and we're going to convert it, which is this one here. Now for you might not have convert here, right? Convert mesh. You may have to go down to modify and choose convert mesh, but I use that all the time, so I just hit these three dots and pinned it to the toolbar, so it's just right here for me. I'll click this one to convert the mesh and accept it. Now, there's a lot of stuff we could do here, but really we don't really care about all those different things. What you really want is to get the profile of this outline, right? So there's, again, many ways to do it. People have all kinds of recommendations, but this is just how I would do it. Now for me, we are finished with that kind of mesh tab. I could easily, get this outline, but I'm assuming that you want to identify the actual width of this, which is going to include this little curve here. Like you mentioned, going through deleting all these things is a real pain in the arse. So what I'll do is I'll go into, create an offset plane. Just clicking the button will give you an offset plane. There's all types of planes, but I'll just create an offset plane. Go about here. We're going to go minus, about 2 millimeters. That's going to create the offset plane for us now. I believe that the reason you can't see it is because I turned my construction planes off. You probably won't have that issue, but once I'm done with it, I like to turn the eyeball off so I can't see it. But here you have a construction plane. You can see that it is down past those curves. So at this point, I'll then split the body. So I'm going to choose split body, pick the body that I want to split, and then pick my splitting tool, which is that offset plane, and we have our next step. Now this is going to obviously create two different pieces now because we split the body. I'm going to remove this top piece just to make it easy. And then I'm going to hide this construction plane, and we're left with this piece here. Now again, as mentioned, there's 1,000 ways to do it, right? So how I'm going to do it is just click on this little sketch button here, create sketch, and I'm essentially going to use project. Similar, I use project all the time, so you may have to go here to create, choose project, hover, hit the three dots and pin it to the toolbar, but mine's here, and so I'm just going to click, obviously I can click an individual line to project that line, but I want to project, the entire outline, so I'm going to just click kind of in the middle here, and we'll say okay. We'll finish that sketch, and now if we hide the body, we are left with just our sketch, and we have the appropriate kind of outline, if you will. Now from here, because it's Fusion 360, you want to have essentially a 3D model. The SVG is good for other things, and hey, maybe SVG DFX files in Fusion 360. I just don't know that, so that's not the route that I go. I usually use a 3D model to get my heights and all my other things set. So here, now that I have my outline, I'm going to extrude this to the thickness of my final part. When I did a test, as a matter of fact, I'll just go back here. Before I split this stuff, I just selected this top surface, hold it, I think it's Control, held that down, clicked the bottom surface, and it gave me 15 millimeters is my total thickness. And so I'll just redo all those steps to get back to where we were, and then I will extrude this 15 millimeters. That's going to give us, the body that we're looking for without the curves, right? Many ways to do this, but this is just the easiest and fastest for me. And so we have our 3D model here. It is laying flat, and we don't have those curved edges, and so we're ready to move on to the manufacturer workspace. So we'll go into manufacturer. The first thing you always got to do is set up, do the setup. Now you can see I've already done this here, so I'll click on setup. Many things. you don't have to select a machine, but I went in and just added some parameters for my machine, so I'll go ahead and select that. The box point for my machine is the lower right-hand corner, so I'll choose that here. You probably the default for most is the lower left-hand corner, but I'll go lower right-hand corner here for this example. Then we'll go into the stock. Now the stock by default always tries to choose this relative size, which I'm sure is great for some things, but for me it's not quite what I want. You can see that this is a little bit thicker than our model, right? We have a 15 millimeter model. Theoretically, the material we're going to use is also 15 millimeters, and so I don't want this kind of 20 millimeter, or I guess it's 16 millimeters, what it chose. So I'll change this to fixed. Let's just say that I'm cutting this out of wood, and my piece of wood is I'll call it 100 millimeters by 100 millimeters. So that's my piece of wood there. And then my piece of wood is actually 15 millimeters thick, so I'll call that. You'll see that the thickness matches, and then we have our length and width that match as well. Now, you see the model is in the center, which may or may not be what you need. If you're trying to save space, then you might reconsider. But here you have the model position, and it's always going to be center because that's what's chosen, right? Z doesn't matter. Our Z matches the exact thickness of the material, so that's not going to matter, right? This little offset piece. Now for the X and Y, personally, I like to go with the X plus and the Y minus for my offsets. You can see that they're still centered, right? And that is 6.6 and 27.3. Now, if we take this to 0, you can see that pushes the model all the way to the right side of the stock. And then if we took this and put it to 0, it'll push it all the way to the bottom of the stock. So here I have this remaining stock left. Now, you obviously want to worry about clamps and the thickness of your bit and whatnot. So typically I don't have this at 0. I have it, between like 3 and 4. The bit that I typically use for these types of things is, 3 millimeters thick. I have a couple clamps, and so I like to have a little bit of an offset off the sides there. So that's what I have done. Now from here, we're ready just to hit OK. That is our setup. We have determined our stock piece and the position of our model within that stock piece. This is a pretty straightforward example, and so I'm just going to go up here to this 2D contour. We'll select the bottom contour here, and we'll go in and select a tool. Now, I won't go too far into this, but I do use the Amana and the Spatool databases. There's obviously a lot of tools in here in both of them. So once I find the tool that I've purchased, searching by the number or what have you, I will just copy that tool. And then I'll come over here into my custom tool database that I created. So these are essentially all the bits that I own. I don't own the rest of them, so I don't really want to have access to them. Plus, it takes forever to find what I need. And so now that I've copied that bit from one of the other databases, come to my custom tool database, and I'll paste that tool. And of course, I don't know which one it was. Must be this one here. I don't know. Let's undo that. Which one did I copy? Gosh dang it. I'll play the video back, but let's just say it was this one that I copied and I am not familiar with it. I'll go ahead and double click on it, and it is going to make that selection for me. Now, this one actually I've already customized because the coolant is disabled. So let me show you here. Let's say that the coolant is not disabled. I'm going to right click, and actually I'll go to my custom tool first. I'm going to right click and go to edit tool. And then here you have your cutting data. This is generally set to flood by default, but I always change it to disabled. That way it just turns it off on this side as well. All right, so you make your selection of your tool, right? Whatever tool you want, just make sure you turn your coolant off, select your tool. We have our contours that we selected. Depending on what you're doing, you may consider adding some tabs. Tabs by distance, we'll just throw a bunch of tabs on here, which is great. It's fine, but I personally like to set my tabs, and so I'll change this to at points, and then I'll strategically place them where I think that I need them based off of, X, Y, and Z criteria, right? You're gonna have to sand these off, so you want to think about, whatever surface they're on, sanding them off is going to make that surface somewhat imperfect, so just something to consider. You can set the thickness and the height of the tabs here. So right now you can see they're only set to 0.3, almost 0.4 millimeters. I can make them 1 millimeter. I can make them, wider. I can make them 4 millimeters wide. You can kind of set up how you want them. You can make them triangles if that's going to be a little easier for you. Just depends on your needs, right? Now, notice that the tab height is 1 millimeter. That's currently going off of the stock bottom, and so when we go to the height tab here, we have a couple things to choose. The first thing I'm going to address is the stock bottom. I'm going to make the stock height, if you will, or bottom height. I'm going to make that reference the stock bottom, and that's just going to move that down. It's going to say, okay, I was referencing the top. Well, now I understand that the bottom is 15 millimeters from the top. Well, if your machine is perfectly tuned and it's a beast, then that's probably going to work for you. My machine is fairly well tuned, but I always find that I need to make a couple extra passes to get it to finally and truly cut out. And so what I'll do is I'll actually set this, this bottom height. It's initially referencing the bottom stock, right, which is minus 15 from the top. And I'm just going to say I want you to go down another millimeter. That way, when you cut, I want you to cut a millimeter deeper than the model. So any sort of like imperfections in my bed, maybe one side is a little bit higher than the other, so one side is completely carved out, but the back side is there's a little bit of material left. And so doing this will really kind of ensure that it gets cleaned up quite well. Now you run the risk of cutting into your bed, of course, so consider that. Consider your clamps, consider your screws, whatever it is that you're holding, whatever it is you're cutting on. So just a simple MDF bed, this is really no issue. So after we have done our heights, we can, or excuse me, I guess the bottom height, we can look at the rest of the stuff here. Top height, you can see, is just saying here's the top of my model, here's the bottom of my model, based off of how I set it. It's actually 1 millimeter lower than the actual model itself. Here is my my feed height, so really like where it's going to start its process, where it's going to start, kind of going into the model. And then you have your clearance height, which is set off of your retract height. This is just saying that for each move. So after, let's say that I do 15 passes to cut this thing out. Well, after each pass, I'm going to move myself up to the clearance height, and then I'm going to come back down. And so I usually just set this to 2. I don't usually use thick clamps, so kind of keep that in mind. Obviously, the higher this is, the more movement the Z is going to make, the more time it's going to take overall. So I usually set this to about 2, which gives me obviously about 7, right? Because it's referencing the retract height. So all that said, just 2, 5, 5, and then -1 is typically what I'll do here. Then we're going to go into our passes. Many things you can do. Again, keep it simple. I just click multiple depths and I choose what do I want each pass to cut. You'll have to, whatever size bit you're using, however fast you're going to go, whatever these parameters are will determine, how deep you can cut, these types of things. So, let's say we just wanted to cut, 1 millimeter passes. So each pass is going to be 1 millimeter. Obviously, it's going to take about 15 passes, right? Because it's 15 millimeters thick, and actually 16 passes because we added that extra millimeter there. So we'll say 1 millimeter passes, and you can see that it's going to generate our toolpath here. And if we go through and we count those, we'll see that there's about 16 of them there. And that's really it, right? So we did our setup. We then chose our contour, and in the contour we specified not only the tool that we're going to use, here's the parameters of the tool, right? How fast it's going to spin, the plunge rate, and all these things. We chose the contour that we're going to cut. We placed some tabs strategically, and we kind of make them meet our needs. We adjusted our bottom so it'll cut all the way through, and to save a little bit of time I made the clearance height just 2 millimeters above the retract height, and then we went in and chose some multiple depths. Now one thing I'm just thinking about here is because we made this bottom height 1 millimeter, minus 1 millimeter, it actually is going to affect our tabs here. And so you'll notice that our tabs actually move down as well 1 millimeter because it's referencing the bottom of that model. And so for this, in order for this to work, we're going to have to compensate for that. So a simple compensation would be just 2 millimeters, right? We might even go back to a rectangle here. Just depends on what you need. You may go 3 millimeters. That's going to actually only be 2 millimeters of the model because one of those millimeters is really going to be, it's basically invisible. It's not going to exist, right? Because this is your work bed, right? Your working surface. So just consider that, play around with that. We'll just hit OK again, and there we have it. There is our, our setup with our tool path, and with all that said and done, I'm just gonna hit this simulate button here, and I'll turn it down a little bit, and I'll hit play. And you can see it goes through, and everything's nice and good until we get towards the end. This bit's not long enough, and so you may choose a more appropriate bit. This speed here is just the speed of the simulation. It's not gonna make it go that fast. Just how fast you want it to get through the simulation. And sometimes you want to go really slow so you can kind of see what's what. Here you can see that it's colliding, and it's going to collide quite a bit. In order for that not to happen, just choose the right bit with the appropriate properties. And that's it, man. That's kind of real quick and dirty. I hope that helps.